Hello everyone, and welcome to the series of NTA NET December 2019 expected questions for computer science and applications. Now, last examination, that is in June examination, we have launched exactly the same series. So these videos that we are publishing here, this is exactly the same videos that we have published in the last session. Now, because students requested us, sir, please publish these videos earlier than the schedule, and they requested us that they wanted these videos and they like this series, so that is why I'm publishing these videos again. I hope that you will like this series, and this series will be very useful for you. Now, if you like these videos, now to support us you can do two things. Number one, you can like the video, just place a like, and secondly, please comment below. So actually YouTube helps the videos which get maximum engagement through likes and comments. So if you really like our videos, if you really like this series, please like and comment under the video. That will be very beneficial for us, and it will help us to grow more and more, and it will help us to post more videos like this. Now, before moving ahead, this is just a very quick announcement for the students who are preparing for NTA NET examination. So whether you're preparing for NTA NET December examination, or whether you're preparing for next year NTA NET June 2020 or December 2020 examination. So right now, because of Diwali festival, we have a huge discount that is going on for our courses. We have various courses, like we have a 3 months preparation course for NTA NET, we have 6 months course, and we have 1 year course, which is having both pre-recorded videos and live sessions. So there are various courses that is present on our website. So if you really like our courses, if you like our videos, it's better that if you want to have a complete lecture series, complete proper comprehensive video materials for NTA NET, please go and check out the courses on our website, or you can just WhatsApp us and call us on this given number, which is 9821876104. So again, as I said, if you want to support us, please like the video, comment under the video, and subscribe to the channel. And don't forget to visit our website, which is www.digimentor.com.
Question number 2 says, consider an experiment of tossing two fair dice, one black and one is red. What is the probability that the number on the black die divides the number on red die? Okay, so we have two dice. One of them is black and one of the dice is red. Okay, so we have right dice, you know what is dice, and we have numbers on dice from 1 to 6. Okay, on both dice, and these two dice are distinguishable by color. Okay, we have black dice and second red dice. So what is the probability that the number on the black die divides the number on red die? Okay, so on black red, number should be like this. Let's say 1 2 3, and the number on this dice can be 1 4 6, like this. Okay, so the number on the black dice 2 should divide the number on the red dice. Okay, so in how many ways we can do this? So total number of possible, let's say you roll 2 dice, and what are the possible values you will get? Okay, you may get, let's say 1 1. 1 1 means 1 on the black dice and red on the 1 on the red dice, or you can say 1 on the black dice and 2 on the red, or you can say 1 3, 1 4, 1 5 and 1 6. This means 1 on the black dice and 2 on the red dice, 3 on the red dice, like this. Okay, so you are throwing 2 dice at one time, and you are looking at the outcomes. So there can be in these ways, outcomes can be in these ways: 2 1, then 2 2 2, 2 1 2 2, 2 3 2 4 2 5 2 6, then 3 1 3 2 3 3 3 4 3 5, like this. 4 1 and 4 to 6, then 5 1 and 5 to 6, 6 1 and 6 6. Okay, so how many combinations can be there? 6 numbers are possible in black dice, 6 possible on red dice. So these are the 30 ways, 6 into 6. So total number of ways equals to 36. Okay, total cases are 36. We can find the outcome in 36 ways. Okay, you roll 2 dice and you can roll these 2 dice in 36 ways. Okay, so you will find a different number in 36 space. The number can be 1 1 1 2 2 1 2 3. Okay, so we are saying on black dice this number and this number on the red dice. So now you need to tell what are the number of possible ways such that the number on the black die divides the number on red die. Okay, so we can have like this 1 1 1 divides 1, yes, or you can say 1 2 1 divides 2, 1 divides everything, 1 divides 3, 1 divides 4, and 1 divides 5, 1 divides 6. Okay, this is okay. This is possible if you have 1 on the black dice and 1 on the red dice. So 1 is dividing 1, this is okay. You have 1 on the black dice and 2 on the red dice. So 1 divides 2. Okay, this is okay. 1 divides 1. Okay, 1 divides 2. This means 1 divides 2. Or you can say 3 divides 1. So this is okay. So now second possible ways are, let's say 2 2. 2 on the black dice and 2 on the red dice. So 2 divides 2. Okay. Second is 2 4, which means 2 divides 4. Yes. 2 divides 6. Okay. Then we can say 3 6. 3 divides 6. Okay. Now we can have 3 3. 3 divides 3, or we can say 4 4, or we can say 5 5, and 5 6. Every number divides by itself. 6 6. Okay. So you can do in these ways. 2 divides 2, 2 divides 4, 2 divides 6, 3 divides 6. Any other way possible? Okay, we have only 2 divides 4, 2 divides 6. We cannot say 1 divides, let's say you cannot say 2 divides 5. So 2 5 is not possible. Okay, 4 6 is not possible. So these are the ways possible. So we can count them: 1 2 3 4 5 6 7 8 9 10 11 12 13 14. So we have total 14 such combinations such that the number on the black die divides the number on the red die, like this. Okay, 1 divides 1, 1 divides 2, 1 divides 3, 2 divides 2, 2 divides 4, 2 divides 6, 3 divides 6. So 3 divides 3, 4 divides 3, 4. Every number is divisible by 1 and every number is divisible by itself. So these are the possible ways. So total number of ways are, so probability equals to total cases, probability equals to favorable cases, which actually are true according to question, favorable cases upon total cases, which means favorable cases are 14 and total cases are 36. So answer is 14 by 36. This is the probability such that every number on black die divides the number on red die. So answer is 3. Question number 3 of UGC net. This question is from counting. Okay. So question is from combinations. In how many ways can 15 indistinguishable fish can be placed into 5 different ponds so that each pond contains at least one fish? Okay. So you have to find in how many ways you can put 15 indistinguishable. Indistinguishable means all are same. Okay. You cannot find the difference between these fishes. Indistinguishable. They cannot be distinguished from each other. Okay. So they are same. Can be placed into 5 different ponds so that each pond contains at least one fish. Or you can say this problem, the question can be asked in many ways. This question can be put in such a way that in how many ways we can put 15 identical balls into 5 different boxes such that each box contains at least one ball. Okay, this question can be formed in this way. Okay, so you have 15 balls, 15 fish, and 5 different ponds. 5 different ponds. So you have to put 15 fishes into 5 different ponds such that each pond contains at least one fish. So any pond cannot be empty. So what you will do is, first you will put one fish into each and every pond. Okay, you will put one fish in 5 ponds, so that condition satisfied, contains at least one fish. Now you have 10 fishes left and 5 ponds. Okay, so you can put all in the same, or you can put in many ways. Okay, now every pond contains at least one fish. Now what you can do is, you can put either all remaining fish into one pond, or you can distribute between these 5 ponds, but condition was at least one fish in each pond. So in how many ways you can do this? This problems becomes same as, you can say you have 5 integers, let's say x1 plus x2 plus x3 plus x4 plus x5. Okay, so the sum of these integers should be 10. In how many ways you can put the digits in these places, x1, x2, x3, x4, x5, such that the sum of these strings is 10. Okay, this problem becomes this. You can put fishes, 10 fishes, you can put these 10 fishes into 5 different ponds like this. Okay, so you have to distribute 10 fishes into these 5 ponds. Okay, so in how many ways you can do this? This condition is now at least one fish. We have already filled this condition, that's why we are left with only 10 fishes. So we are doing this for only 10 fishes. So we know the formula for this: n plus k minus 1 c k minus 1. Okay, so this is the formula for putting n fishes into k different ponds, such that each pond contains at least one fish. So this can be, okay, we have 10 plus 5 minus 1 c 5 minus 1. So this is 14 c 4. Okay, so solve this. You can say this formula is same as putting 15 identical balls into 5 different boxes, such that each and every box contains at least one ball. Okay, balls are identical. Identical means they are indistinguishable. The formula will be same. So this question can be asked in many ways. So try to find out the value of 14C4. 14C4 will be 14 factorial upon 14 minus 4, that is n minus r factorial, 10 factorial into r factorial, that is 4 factorial. So this is the formula for NCR, n factorial upon n minus r factorial into r factorial. So this is 14 into 13 into 12 into 11 into 10 factorial upon 10 factorial into 4 factorial. Okay, so 10 factorial will be finished. 4 factorial means 4 into 3 into 2, that is 14 into 13 into 12 into 11 divided by 4 into 3 into 2. This is the value of 4 factorial. So 4 into 3 will be 12 and this will be 7. So now we are left with 13 into 11 into 7. So find out the value of this: 13 into 77. So this will be 13 into 7 into 7, that is 1001. So this will be the answer for this question, that is option 1. Okay, so you need to remember this formula, or you can see the proof of this formula for NCERT or 12th mathematical class book of this. For this formula you can find the combination chapter from 12th book of NCERT, and you can see how we calculated this formula: n plus k minus 1 c k minus 1. Okay, so formula is different from, we have two formulas such that the putting 15 indistinguishable identical balls into 5 different boxes, such that at least each contains at least one fish. Okay, or we can say such that there's at least this condition is omitted. Let's say not at least one. Okay, there can be 0 fish also, or all 15 fishes can be in one box. So in this case, formula will be modified like this: n plus k minus 1 ck. Okay, that formula will be n plus 1 k minus 1 ck. So now we have to put at least one fish into each and every pond. So the formula will be n plus k minus 1 ck minus 1. Okay, so the value of this will be 10 plus 5 minus 1 c5. Okay. Question number 8 says, if my computations are correct and I pay the electric bill, then I will run out of money. Okay. So let's try to read the question first. We have question: convert these arguments into logical notations using the variables C, B, R, P for C for proposition, C for computation, B for electric bills, R for out of money, and P as power. Okay. So we have these 4 variables, and the equivalence of these 4 variables are these. So we have to use these variables to convert these arguments into logical notations. Okay, so logical notations are like this. If you have something like if P then Q, this means P implies Q. Okay, if you have something like this, if P and Q are true, then R. So this will be equal to equivalent logical notations. P implies Q implies R. P and Q implies R. Okay, so this will be the equivalence to this. Okay, let's try to read the arguments. If first argument says, if my computations are correct and I pay the electrical bill, then I will run out of money. So we have 3 parts: P and Q, then R. So what we can say is computations is C for computation. Okay, so if my computations are correct, C means computations are correct, and I pay the electric bill, that is B. Then if my computations are correct and I pay the electric bill, then this means I will run out of money. Running out of money means R. Okay, so this will be equivalent to first argument. Second argument says, if I don't pay the electric bill, the power will be turned off. Then power will be turned off. For paying the electric bill is B. Not paying the electric bill means not B. So if not B, if I don't pay the electric bill, then power will be turned off. Power is on means P, and power is off means not of P. So second is this. We have third argument, and third argument says, therefore if I don't run out of money and the power is still on, then my computations are incorrect. Okay, running out of money means R, and if I don't run out of money means not of R. If I run out of money, running out of money means R, and not running out of money means not of R. So which means if I don't run out of money, that is not of R. Okay, and power is still on. Power on means P, not of R and P. This implies that my computations are incorrect. Okay, so this means I can say computations are correct means C, computations means C, computations correct means C, and computations are incorrect means not C, which means not C. Okay, so this will be the equivalent logical notation for third argument. Okay, let's try to find out the options. If C and B implies R, this is okay. Not of B implies not of P, this is okay. Not of R and P implies not of C. Okay, this is the answer. All where we are using OR, these options are incorrect. Okay, these options are definitely incorrect where we are using OR, because in our logical, in our arguments we are using AND. Okay, in our logical in our arguments we are using AND, so that's why OR is wrong. So we have option 1 and option 3 to choose between. Okay, so why option 3 is incorrect? This is saying not of R or P, which is incorrect. We have to use AND. Okay, so this is the right answer. Okay, in question number 9 we have some list 1 and list 2. So we have to match list 1 from these list 1 elements to list 2. Okay, So here we have some arguments, some laws, and we have to match them according to their logical notations. Okay, what are the logical notation for contrapositive, exportation law, reductio ad absurdum, and equivalence? Okay, so let's try to find out the meaning of these: contrapositive, exportation law, reductio ad absurdum, and equivalence. Okay, first one is contrapositive. Contrapositive means, okay, we have some important terms related to P implies Q. Okay, so we have, if we have P implies Q, the inverse of this is Q implies P. Inverse of this is not of P implies not of Q. And converse of this is Q implies P. This is the converse of P implies Q. Okay, then we have contrapositive. Contrapositive means inverse of converse, that is not of Q implies not of P. Okay, so P, every logical notation like this, P implies Q is equivalent to its contrapositive. We can say P implies Q is same as writing not of Q implies not of P. These two will always give you a same result. Okay, so every logical notation is equivalent to its contrapositive. Okay, this is the contrapositive of P implies Q. So okay, this is contrapositive. Second is exportation law. Exportation law says, if we have something like this, exportation law says, if we have something like this, P and Q implies R, then we can simply say P implies Q implies R. Okay, these are the same. They are equivalent to each other. P and Q implies R and P implies Q implies R. These are the same. This is according to exportation law. Exportation law means, let's say P is you qualify, let's say P is you qualify assistant professor of UGC and Q is you qualify JRF of UGC net. Okay, so and R is you are brilliant. Okay, so this statement is saying if you qualify assistant professor and JRF of UGC net, then you are brilliant. Okay, this says if you qualify assistant professor and JRF exam of UGC net, then you are excellent. If you qualify only P, let's say if you qualify only assistant professor, then you are not brilliant. So this is same as saying if P implies Q implies R, that means if you qualify assistant professor, then I have to check for Q implies R. That means then I have to check whether you have qualified JRF or not. Then I will check if you qualify assistant professor, then check for JRF. If you qualify JRF, then you are brilliant. Okay, so P implies Q implies R. Okay, so P equal to you qualify assistant professor, Q implies you qualify JRF. This means P, if you qualify assistant professor and JRF, then you are brilliant. Okay, so P, this one is also saying the same thing. So this is exportation law. You can write P and Q implies R as P implies Q implies R. So this. So third is reductio ad absurdum. In this what we do is we take an argument Q and say Q is true. Then from this we deduce that Q is true. And then we deduce that Q is false. Okay, we deduce that Q is false. So this implies that Q is implying Q and Q is implying not Q. So this cannot happen. This is contradiction. This always be contradiction, because P cannot imply both Q and not Q. Okay, if P implies both Q and not of Q, then this is contradiction. Okay, so first we take an argument, then we prove that this argument cannot be true. Okay, so this is reductio ad absurdum. Equivalence means P equivalence Q. This is the equivalence, and this means this is equivalent to P implies Q and Q implies P. Okay, this is the equivalence of equivalence. P double implies Q. This means P implies Q and Q implies P. Okay, so let's try to match. Contrapositive means a statement is equal to its contrapositive. Okay, so A implies first one, then P and Q implies R is same as saying P implies Q implies R. So this is exportation law. Okay, so the example which I gave here was, if I qualify assistant professor and JRF net, then I am brilliant. This says that. So this logical formula is saying this is equivalent to this. This means if I qualify assistant professor, this means I have to check for JRF. Okay, then I will check if I qualify JRF, then I am brilliant. Okay, so this is same as this. Okay, so in reflective absurdum, we take an argument. Okay, P implies Q is same as P and not Q and O. So in this we are saying that P is implying to Q and not Q. This cannot happen. So this is contradiction, which means this is absurdum. Okay, P equivalence Q means P implies Q is same as saying P implies Q and Q implies P. So this. So A is 1, B is 2, C is 3 and D is 4. 1, 2, 3, 4. So we have the answer 1. Question number 4 of UGC NET December 2016. What is the probability that a randomly selected bit string of length 10 is a palindrome? Okay. So what is palindrome? Palindrome means string is same from both sides. If you read string from any side, it will be same. Okay. 101, 101. Okay. Or 110, 11, 110, 11. So second part of the string is same as the image of first part. Okay, so how many strings we can have with length 10? With length 10, let's say with length 2, how many strings are possible with length 2? And this is bit string. Remember, this is bit string. Bit string means 0 or 1. We can use only 2 digits to form a number, 0 or 1. So we have 2-digit number. Length of string is 2. So either we can have 0 or 1 here, or we can have 0 or 1 here. So how many possible numbers? 0, 0, 0, 1, 1, 0, 1, 1, 4. Okay. So like this, if we have a length of 3, then 2 to the power 3. Length 10, 2 to the power 10. So we have total this number of strings with length 10. These are the total number of strings. Total number of strings with length 10. Okay. So these are the total number of strings, and we are interested in only palindrome strings. So how many strings will be palindrome out of these strings? Palindrome means we have palindrome of length 10. So palindrome means we have choice for half part, and next half part will be the image of this one. We do not have any choice. We cannot put anything in second half part, but we will have to use this number in second part. Okay. If we have 11010 in first part, then second part will also be same, 01011. Okay, this is palindrome number. So we have choice for first 5 digits and no choice for last 5 digits. So with first 5 digits we can form number in 2 to the power form, 2 to the power choices. Okay, we can have 1 or 0 here, 1 or 0 here, 1 or 0 here. So 2 into 2 into 2 into 2. So we have 2 to the power 5. So number of probability will be favorable cases upon total cases, which means 2 to the power 5 upon 2 to the power 10, that is 1 upon 32. Question answer is 2. Okay, we have question number 5. Question number 5 says we have two graphs G1 and G2. So we have to check whether G1 and G2 contains Euler circuit or not. Okay, so what do you mean by Euler circuit? First let's look at the Euler path. Euler path says you should be able to cover each and every edge once. Okay, only once. Then the graph have a Euler path. If you can visit each and every edge once, then the graph is Euler graph. Okay, so we can have Euler path in this. But what is Euler circuit? Euler circuit is closed Euler path. What does we mean by closed? Closed means starting and ending point should be same. Okay, if we want an Euler circuit, then starting and ending point should be same of the circuit. So Euler path means we should be able to cover each and every edge once, only once. Edge cannot be repeated, but a vertex can be repeated. Starting and ending vertex can be repeated, because we will start from here and we will reach here. Okay, so let's check these graphs for Euler circuit. Okay, so we know one thing. This is a theorem of Euler graph, and the theorem is, if we have any odd degree vertex in graph, then graph cannot have a Euler circuit. Okay, this is first thing. There are two ways to know whether this graph contains Euler circuit or not. First is you can manually check by finding a path in this graph, or you can apply this theorem. Why we are saying if there is a odd degree vertex, then graph does not have a Euler circuit? Because there should be one out path and one in path in every vertex. Okay, we can come into this vertex and we can come to out. Okay, so if I take this vertex, I can go out from this vertex and come to the vertex, but I cannot cover this one, so this will not have a Euler path. Okay, so if from the theorem this edge has 3 degree, so we have a vertex in this graph which have a odd degree, so graph is not Euler. Second graph is 1 2 3. A is with 3 vertex with 3 degree, and C is 4, E is 6, D is 3. Okay, so we have 2 vertices of degree odd, so we cannot have Euler circuit in this graph. So there should not be any vertex of odd degree. If all of the vertices are of even degree, then we can have Euler circuit. But even if one odd degree vertex can violate the condition of Euler circuit. Okay, so none of them is Euler circuit, contains Euler circuit. The answer is, okay, we have question number 5. Question number 5 says we have two graphs, G1 and G2. So we have to check whether G1 and G2 contains Euler circuit or not. Okay, so what do you mean by Euler circuit? First let's look at the Euler path. Euler path says you should be able to cover each and every edge once. Okay, only once. Then the graph have a Euler path. If you can visit each and every edge once, then the graph is Euler graph. Okay, so we can have Euler path in this. But what is Euler circuit? Euler circuit is closed Euler path. what does we mean by closed? Closed means starting and ending point should be same. Okay, if we want an Euler circuit, then starting and ending point should be same of the circuit. So Euler path means we should be able to cover each and every edge once, only once. Edge cannot be repeated, but a vertex can be repeated. Starting and ending vertex can be repeated, because we will start from here and we will reach here. Okay, so let's check these graphs for Euler circuit. Okay, so we know one thing. This is a theorem of Euler graph, and the theorem is, if we have any odd degree vertex in graph, then graph cannot have a Euler circuit. Okay, this is first thing. There are two ways to know whether this graph contains Euler circuit or not. First is you can manually check by finding a path in this graph, or you can apply this theorem. Why we are saying if there is a odd degree vertex, then graph does not have a Euler circuit? Because there should be one out path and one in path in every vertex. Okay, we can come into this vertex and we can come to out. Okay, so if I take this vertex, I can go out from this vertex and come to the vertex, but I cannot cover this one, so this will not have a Euler path. Okay, so if from the theorem this edge has 3 degree, so we have a vertex in this graph which have a odd degree, so graph is not Euler. Second graph is 1 2 3. A is with 3 vertex with 3 degree, and C is 4, E is 6, D is 3. Okay, so we have 2 vertices of degree odd, so we cannot have Euler circuit in this graph. So there should not be any vertex of odd degree. If all of the vertices are of even degree, then we can have Euler circuit. But even if one odd degree vertex can violate the condition of Euler circuit. Okay, so none of them is Euler circuit, contains Euler circuit. The answer is,
in this series of videos, we are going to solve some previous year questions which are asked in UGC NET examination. And here we have taken the January 28, 2017 examination for UGC NET Computer Science, and we'll try to solve the entire question paper, that is paper 2 as well as the paper 3 for the solutions. Okay, so here we will start with the paper 2, and the first question from paper 2 is from this propositional logic, and or you can say they are giving some Boolean functions here, and we will try to solve this complete question. And let us start from here, and we'll create videos for every question. So the videos will be arranged question by question. You can go through the website, you can try solving your this previous year question, and if you face any difficulty, if you stuck at any point, then you can just refer to these videos and you will be able to solve this. You will be able to get a proper solution of these questions. Okay, so this first question is from Boolean functions, and so this first question is from Boolean functions. So you can see they are giving this function which is represented by negation of P and Q, and negation of P and negation of Q, or P and R. So I prefer writing these kinds of statements in Boolean in digital logic kind of statement, Boolean algebra, because that makes it very easy to solve for me. So but sometimes it can create problems, that I'll show you some specific cases when we will discuss about that. So you can see I can convert the entire statement into this particular way. We have P complement dot Q whole complement dot, we have P complement dot Q complement whole complement. So you can see if this is P complement here, if this is representing P complement, so I've taken this P complement and negation of P I converted to P complement, and we have converted this and to dot, and here we have negation of this complete P and Q, so you can see I converted it to complement like this. In the same way you can convert this entire statement, as well as then you can take this statement to solve it. So you can write it like this, P dot R. Now you can apply some basic digital logic formulas, like here we can apply De Morgan's law, and here also we can apply De Morgan's law to solve these statements. So if you apply De Morgan's law here, so this can be written as P plus Q complement dot, if you apply De Morgan's law here, it can be written as P plus Q plus P dot R. Now you can expand this here, so this can be written as P dot P plus P dot Q plus P dot Q complement plus Q complement dot Q plus P dot R. So this can be written as P plus PQ plus PQ complement plus this complete is false, or you can say it is 0, plus PR. Now if it is 0, so you can exclude this one, you don't need to include this one here. So this complete expression can also be written like this, P plus PQ plus PQ complement plus PR. Now from this complete expression you can take P as common, so this expression can be written like this. So it can be written like this, P, it is 1 plus PQ plus PQ complement plus PR, and because we have a 1 here, because of this 1, this entire expression will become 1, therefore this entire expression is going to give us P only. That is, the answer is option number 4, that is P. Okay, now let us look at the second question. Here they are saying that let A and B be the sets in a finite universal set U, and this universal set U can be anything, and given the following, that A minus B, the cardinality of A minus B, cardinality of A XOR B, cardinality of A plus cardinality of B, and cardinality of A union cardinality of A union B. Okay, they are saying which of the following is in order of increasing size. Okay, let us assume it like this, assuming that we have a set A which is having the following elements 1, 2, 4, 6, 7. There's a set B which is having the elements 3, 5, 6 and 7. Okay, now if I do these are the two sets. Now if I do what is the cardinality of A plus cardinality of B. So cardinality of A is the number of elements which A is containing, that is 5. At cardinality of B is the number of elements which B is containing, that is 4. So cardinality of A plus B is 9. And assuming that the universal set is like this, 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. This is representing the universal set. Now next is if I do A union B, then A union B is going to be a set which is having the elements which are in A and in B, but the elements will not be repeated. Okay, like for example, if I do A union B, then we are going to have 1, 2, 3, 4, 5, 6 and 7. Therefore the cardinality of A union B is going to be 7. Okay, now if I do A XOR B, A XOR B means, what is an XOR? Like if you draw an XOR, either it should be present in A but not in B, right? Or it should be present it should be present in B but not in A. So if I do A XOR B, then it is going to be give us the values which are 1, 2, 4 and 5. 1, 2, 4 and 5 and 3. So 1, 2, 3, 4, 5. So these are A XOR B. So cardinality of A XOR B is going to be 5. If I say what is A minus B. Then A minus B is the elements which are present in B that will be subtracted from A. So A minus B is going to give us 1, 2 and 4. So cardinality of A minus B is 3. Right, so you can see they are asking which of the following is in order of increasing size. So the maximum size is for A, cardinality of A plus cardinality of B, that is 9. The next is cardinality of A union B. Then the next is cardinality of A XOR B, and the next is cardinality of A minus B. Therefore, here the option number 4 is correct. So this question was asked in this question was asked in UGC NET Computer Science 28th August 2016. So now let us look at the next question. That is the question number 4. And in this question you can see they are saying that what is the probability that a randomly selected bit string of length 10 is a palindrome or not. It is a palindrome or not. So for this, let us see if we take a string, and when can we say that string is a palindrome? If we have string like this 11011, now here you can say this string is a palindrome. Why? Because if you read from the left direction or if you read from the right, you'll read the same string. Now if you have a string like this 111001111, so even if you read from the left or even if you read from the right, it will say the string is exactly the same. But what is the difference between these two strings is that this string is of odd length and this string is of even length, and here the length they are giving is exactly even length. It is not an odd length. Now if you say there are 10 combinations, there are 10 combinations of ones are present, so assuming these blocks are representing those 10 combinations, 4 5 6 7 8 9 and 10. Now when I say the string is a palindrome, that means if we take any combination of the first 5 string, that exact same combination should also be present here. Like if we have a combination 11001, then this exact same combination should be present here in a reversed order like this 11001. Now you can see these strings are repeating themselves, so therefore this complete is representing a palindrome. Okay, now if this complete is representing a palindrome, then you can see this first 5 should be exactly equal to the last 5. Now what are the different combinations which are present for the first 5 strings? So here we have two choices. It can take two combinations, that is either it can take 0 or it can take a value 1. This can take 2 values, this can take 2 values, this can take 2 values, and this can take 2 values. All these combinations can take 2 different values of, or you can say 2 different combinations. Why? Because it is a bit string. So a bit can be 0 or it can be 1. So in total these 5 combinations, there are 2 raised to power 5 such combinations are present, that is 2 into 2 into 2 into 2. That means for the first 5 bits there are 2 raised to power 5 such combinations are present, and those exact combinations should also be here. And in total, if we check in total, there are 2 raised to power 10 combinations which can be there. Now if a string now if you want to see how many strings are there which are palindrome, so this can be written as 2 raised to power 10 divided by 2 raised to power 5, right? So because all these exact same combinations should also be present here, so which is equal to 2 raised to power 5. Therefore you can say, which is, okay, so I should write it, I should have written like this, because they are saying probability. They are saying what is the probability that randomly selected string is a palindrome. So probability. So what is probability is the number of favorable events divided by total number of events. So here we have 2 raised to power 5 combinations which can be there, which are presenting a palindrome, and total we have 2 raised to power 10 combinations. So we are having 2 raised to power 5 divided by 2 raised to power 10, which is 1 upon 2 raised to power 10 minus 5, which is 1 upon 2 raised to power 5, or 1 upon 32. So if we select a string randomly, then it is 1 upon 32 probability that that particular string is a palindrome of length 10. Therefore you can see here the answer is option number 2, which is 1 upon 2 raised to power 32. And this question was asked in UGC NET CSE 28th August 2016. Now let us look at the question number. Now let us look at this question. In this question is based on Euler graph, and we know what is a Euler graph and a Hamiltonian graph. For revision purposes, let me explain it again. We have Euler path. Euler path means if we have a graph like this, then we want to visit every edge exactly once, right? For example, you can visit any vertices any number of times. You can visit a vertex more than one number of times, but you have to visit an edge exactly once. So when I'm saying Euler path, that means you start from an edge, or you can start from a vertex, visit all the edges exactly once like this. So for this graph, the Euler path does exist. And when I'm saying Euler cycle or Euler circuit, it means that you have to come back to the starting location itself. Like for example, for the same graph, if this was a graph which we discussed, now in the same graph, if we start from these vertices, then there exists an Euler path, but there does not exist a Euler cycle, because you have to come back to the starting vertex and you don't have to visit the edge more than one time. Now if we have a graph like this, now for this graph, the Euler cycle does exist. How? You can visit it like this, you can visit the edges like this, and then you can come back to the starting vertex after visiting all the edges. So you can see you are coming back to the starting vertex here. So there does exist a Euler cycle, or you can say Euler circuit. Now for what is the necessary condition for Euler circuit? The necessary condition is the degree of every vertex should be even. First condition is, or first necessary condition is, the degree of every vertex should be even. If in a graph the degree of all the vertices is are not even, then Euler cycle does not exist. For you can see here in this graph, the degree of these two vertices is odd. So you can see in these two graphs, the Euler circuit does not exist. Euler path may exist, but Euler circuit does not exist. And here in this graph, the degree of every vertex is even, therefore Euler circuit is existing here. So you can see in both the graphs here, here the degree of this vertex is odd, degree of this vertex is odd, and the degree of this vertex is odd, degree of this vertex is odd. Therefore this graph is not having a Euler circuit. Here the degree of these two vertices are odd, therefore this graph is not having a Euler circuit. Hence both G1 and G2, they are not having any Euler circuit. Okay, so option number A1 is false, option number 2 is false, option number 3 is true, or you can say option number 3 is right, and option number D, or you can say option number 4 is false. Okay, so now let us look at the question number.
Question number 3 says, let A and B be two sets in a finite universal set U. Given the following: A minus B, A symmetric difference B, A plus B, and A union B. So these are the mode. It means we need to find out the number of elements in this operation after performing this operation. Okay, so let's take example. A equals to 1, 2, 3, 4. In such type of question, we can easily solve such type of question by taking the examples. Okay, take small example. A equals to 1, 2, 3, 4, and B equals to 2, 3, 4, 5. Okay, now let's find out A minus B. So A minus B is those element of A which are not in B, that is 1. Okay, so the mode of this is the number of elements in A minus B is 1. Okay, in A symmetric difference B, we have A symmetric difference B, and the meaning of this operation is A minus B union B minus A. Okay, A minus B union B minus A. So what is A minus B? A minus B is 1. Union, what is B minus A? Those elements of B which are not in A. 2, 3, 4, 5. We do not have 5 in A. So 1 union 5 equals to 1, 5. So we have 2 elements in this operation. Okay, now let's look at the A plus B. So A plus B. How many elements in A? 4. How many elements in B? 4. So total 8 elements. A union B. A union B will be A union B 1, 2, 3, 4, 5. So how many elements are there in this? 5. So largest is, we have to take in increasing size. Okay, increasing size. So smallest is A minus B. Then we have symmetric difference, that is A symmetric difference B. Next is A union B. And largest set is your A plus B. So the correct answer is A minus B XOR B. Question number 10 says, consider a proposition given as x greater than equals to 6 if x square greater than equals to 25, and its proof is given like this. Okay, its proof is given like this. If x greater than equals to 6, then x square equals to x into x greater than equals to 6.6 equals to 36 greater than equals to 25. Okay, we have to tell which of the following is correct with respect to the given proposition and its proof. A says the proof shows the converse of what it is to be proved. Okay, B is saying the proof starts by assuming what is to be shown. C is saying the proof is correct and there is nothing wrong. Okay, so we have to find something like this. Okay, so let's say we have x greater than equals to 6. Okay, if x square greater than equals to 25, what we can say is, we can consider this as P and this one is Q. Okay, so this is same as saying if Q then P, or we can say P if Q, or we can say P whenever Q. Okay, all of these are same. So according to this can be written as, so this first sentence can be written as Q implies P. Okay, second one is saying if x greater than equals to 6, then x square equals to 25. Okay, we know this is your P and this is your Q. Okay, this is if P then Q. What we can say about if P then Q? If P then Q, this is your P implies Q. Okay, so here we can say this is saying P implies Q. So let's try to read the options. A is saying the proof shows the converse of what is to be proved. Okay, so we have to prove this and this is the proof. So this is saying this is okay. Why? Because we have this is something to be shown and this is your proof. Okay, the proof shown the converse of what is to be proved. Okay, so this is your this is converse of this. Converse of this is Q implies P, and contrapositive is not of Q implies not of P. Okay, so you can say this is okay. The proof shows the converse of what is to be proved. We have to prove this and this is your proof. Okay, so this is converse of this. The proof starts by assuming what is to be shown. Okay, we have to show this, and in the proof this is your proof. In the proof we are using this. Okay, we have to show this and this is being used here, x greater than equals to 6. Okay, we are proving using the sentence itself. Okay, this is to be proved and this itself is used in the proof. Okay, you can see like this. So second also true. The proof is correct and there is nothing wrong. Okay, this is wrong. Why? Because this proof does not follow any logic formula, any logic standards. Okay, so we have first order logic, and first order logic standards are not followed in this proof. So that's why this is wrong. According to logic, we cannot prove something by taking something which need to be proved. Okay, this need to be proved, and itself we are using this in the proof itself. So this is wrong. And A and B are correct. So C is the answer. Third is the answer.
Hello everyone, and welcome to the series of NTA NET December 2019 expected questions for computer science and applications. Now, last examination, that is in June examination, we have launched exactly the same series. So these videos that we are publishing here, this is exactly the same videos that we have published in the last session. Now, because students requested us, sir, please publish these videos earlier than the schedule, and they requested us that they wanted these videos and they like this series, so that is why I'm publishing these videos again. I hope that you will like this series, and this series will be very useful for you. Now, if you like these videos, now to support us you can do two things. Number one, you can like the video, just place a like, and secondly, please comment below. So actually YouTube helps the videos which get maximum engagement through likes and comments. So if you really like our videos, if you really like this series, please like and comment under the video. That will be very beneficial for us, and it will help us to grow more and more, and it will help us to post more videos like this. Now, before moving ahead, this is just a very quick announcement for the students who are preparing for NTA NET examination. So whether you're preparing for NTA NET December examination, or whether you're preparing for next year NTA NET June 2020 or December 2020 examination. So right now, because of Diwali festival, we have a huge discount that is going on for our courses. We have various courses, like we have a 3 months preparation course for NTA NET, we have 6 months course, and we have 1 year course, which is having both pre-recorded videos and live sessions. So there are various courses that is present on our website. So if you really like our courses, if you like our videos, it's better that if you want to have a complete lecture series, complete proper comprehensive video materials for NTA NET, please go and check out the courses on our website, or you can just WhatsApp us and call us on this given number, which is 9821876104. So again, as I said, if you want to support us, please like the video, comment under the video, and subscribe to the channel. And don't forget to visit our website, which is www.digimentor.com.